joining the session today. I'm Steve Wright. I'm a Senior Database Solutions Architect with SolarWinds. Nothing about the session today is any kind of SolarWinds product demo or anything like that. This is strictly issues I've dealt with, working with our customers, working with Azure Synapse Analytics. Common issues, also having a lot of conversations with Microsoft support engineers and PMs and that sort of thing. And also, just issues in the field and how to discover them and what to do about them. In the time that we have, there's 5 of them that I'm really going to focus on here. And hopefully you'll find that information useful. There are some scripts. I'll do some short little demos. And I'll share some links at the end for those as well, so you can try them out for yourself. So I'll start, first of all, with just a brief overview. So dedicated SQL pools in Azure Synapse Analytics were the feature product, formerly known as Azure SQL Data Warehouse. So, it's based on the massively parallel processing architecture. You may also be familiar with the on-prem predecessor of that, the APS appliance that Microsoft offered, also generally known, parallel data warehouse. So the dedicated SQL pools, as they're known now in Azure Synapse, are based on that same architecture. And obviously, it's important to understand that architecture, especially as compared to the standard SQL Server architecture and how that product works when you're troubleshooting these particular issues. And you see the list there. I've pulled out 5 that, in my experience, have been the most common. Again, even just in the field, as well as talking to Microsoft engineers themselves. And we'll make sure we have some time. We'll wrap up with some Q&A. So just briefly about myself, like I said, I'm a Senior Database Solutions Architect at SolarWinds. I joined SolarWinds as when they acquired. I was previously with SentryOne about 2.5 years ago. Between those 2 organizations, I've spent 18 years in various roles in support of our database monitoring observability tools. My focus has been the Microsoft data platform. We do have SolarWinds has solutions supporting other platforms as well. Obviously, Oracle, Postgres, those types of things. But I've spent the bulk of my time in the Microsoft space across various organizations within the company, data science, data engineering, all of that. And I actually was the product manager for our solution that supports monitoring, originally Azure Data Warehouse back then. So that's where I gained a lot of this insight and continue to support our customers that use that functionality today. I'm working out of, I live in Charlotte, North Carolina, so I'm in the East Coast of the United States. I saw earlier people were asking, the worst time zone. Someone quickly jumped in before me. Mentioned the Central Time Zone, which is an hour even earlier than myself. So I didn't even bother jumping in there. It's 9 a.m., so it's a reasonable hour for me today anyway. So I've been on for a couple hours to watch the sessions that I could as well. You see my information there. If you have any follow-up questions, you can find me on LinkedIn. THWAC is a SolarWinds community resource that I'm on, and we're continuing to build out, especially in the data space there. A lot of you may know SolarWinds for long-term familiar, really started in the network space, and obviously are building out in the database space over the last several years now with the acquisition of SentryOne and other solutions. And then my Twitter handle there as well. So before I jump into the session, I just wanted to take a quick poll here. You just drop something in the chat if you get a chance. I didn't set up a formal poll or anything, but I always like to just get an idea of the audience. And so if feel free to, if you got a comment in there, to let me know what your current experience is. Are you actively working with Synapse and dedicated SQL pools? Are you familiar with the MPP architecture, or are you just looking to maybe learn something new? Maybe just getting started. It was so great. Hopefully you'll learn some of the common pitfalls to watch out for, and you'll be ahead of the game. Obviously, I want to review the MPP architecture. It's kind of foundational to everything else we're going to talk about, but I don't want to spend too much time if we're dealing with a bunch of experts either. So if you get a chance to drop something like that in the chat, I'll make sure to kind of gear things accordingly. Of course, I'm talking specifically about the dedicated pools. I say, yep, to some all the way back to when it was PDW, like I said, yeah. And I worked with, said when we supported Azure SQL Data Warehouse, we also supported that APS appliance on-prem as well. So yeah, going back several years now. But with that, like I said, it's kind of foundational. So I do want to start just briefly with just a walkthrough of the basic architecture of the dedicated SQL pools and how this works. Like I said, it's foundational to the problems. It's foundational to how it performs so well with big data, and it's also foundational to how you can run into issues and not get the performance you'd expect from something where you are scaling out, massively, as the term indicates there, to expect, big performance gains over using the, standard SMP product like standard SQL Server or anything else like that. So essentially, just to explain, so you can kind of think of these, you see there's various nodes here. There's one control node and any number of underlying compute nodes, anywhere from 1 to 60 with the dedicated pools here. And you can think of them as essentially their own SQL Server instance. And I see some people, some for a long time, some gave it a look and quickly got frustrated with it. Yeah, it's like I said, I definitely understand that. So this will be good. Hopefully gain some new insight on how to identify, where it gets complicated, how to quickly identify those and resolve them. Like I said, you can think of each of these nodes basically as their own standalone SQL Server. And then that data, in order to scale out and get that massively parallel performance, each table essentially is sharded into 60 distributions. And then, of course, depending on the service tier that you've specified with your service pool, your SQL pool, it will determine the number of compute nodes you have, and then that number, then the distributions that each of their own segments of that data is allotted to, assign to essentially each of those compute nodes. So obviously, if you're at the lowest tier, you only have one compute node, you're not really massively parallel at that point, but it does function that one compute node's working with all 60 distributions. If you scale up to the very top level tier, you've got 60 compute nodes, each responsible for only one of those distributions. And that's where you really get that scale out functionality. They're all focused just on their piece of the data, which in theory can give you massive gains in performance when you're dealing with data that you can be measuring in terabytes and so forth. But it really is dependent on how you distribute that data, the nature of the workload, how you're querying the data, and other factors that we'll take a look at here. So you see there are really three main ways to distribute your tables across those 60 distributions. So hash being the most important. That's where you identify a key that you are going to then determine, okay, everything that matches that key is going to be assigned to a particular distribution. And that's how the data is distributed across there. Where round robin is just like it sounds. You're going to evenly distribute the data. It's, by the way, the underlying storage in the dedicated SQL pools is clustered column store indexing. So, if you're familiar with that technology, that might help to understand how things are distributed here based on those columns, and then replicated. If the table is small enough, instead of distributing it across those 60 distributions, you actually just allow each node to have its own copy of that table. Might be, particularly useful. It's smaller tables, they're static, that, dimension tables versus fact tables that are likely to, again, be static and smaller than the rest of your data. We'll talk a little bit more about that. But those are the three different ways you can distribute the data. And a lot of this, functionality is really going to hinge on how you distribute it and choosing that hash, choosing that key to distribute that data. just go into a little more detail there. Considerations. Okay, how do I determine which makes sense for me for a particular table that I'm dealing with here? And a lot of it is going to be very dependent on knowing the workload. And this, so because that workload, you might not know it all up front when you're first setting things up. And of course, workloads can change. All of this tends to be an iterative process, right? So when I talk about identifying these issues and resolving them, it's something that's you're probably going to iterate through over time to identify those issues that might pop up as things change. So obviously with your hash distribution, one of the first things you want to consider for that distribution key is the distinctness of the data. In a nutshell, the reason for that is going to be that if the data isn't, say there's one value that you've chosen in that key for distribution that maybe is common to say half your data in that table, then all of that's going to end up on one distribution, and you're going to end up with what you see in the next there, data skew, right? Where you're because most of your data ends up in one or two distributions, possibly depending on the distinctness, as opposed to being evenly distributed as much as within reason. When you're querying that data, remember, depending on how many compute nodes they have, if certain compute nodes essentially get assigned the certain distributions based on how many compute nodes there are, you're essentially likely, based on that data, that the one compute node that has the distribution where most of that data landed is going to be doing most of the work as opposed to the other compute nodes, and you tend to defeat the purpose of scaling out in the first place. So that's an important consideration when you're determining how to distribute your data. And then, like I said, most importantly, and this is again going to be part of that iterative process, are the typical queries, the workload. In particular, joins and group bys, because we talk about this first issue you see here that I have at the top here, data movement. Because the data is split across these distributions, regardless how many compute nodes you have, when you have to do joins with tables, depending on how that data is distributed, copies of some of the data may need to be moved from one compute node to another so it can do a proper join or aggregation on the data it has access to. So depending on your selection of that hash, when you distribute the data, it's going to, in that workload, joins and aggregations are going to determine how much of that data movement is going to happen. Data movement, by the way, basically is the most common issue that results in queries running longer than they need to. So you put in your request, you got to join on a couple of tables in your data, but because the join isn't optimized based on how you distributed that data, you're spending a lot of time having data being shuffled around between compute nodes so that proper joins or aggregations can occur there before the final results can be produced and returned back up through the control node to the end user there. So understanding the workload ultimately and how that data is joined and aggregated plays probably the most important role in how you're going to choose to distribute that data. With round robin, that's common, especially if you don't know upfront what's the workload going to look like. Oftentimes you're going to start with that round robin distribution. I don't know. Let's evenly distribute everything across all of the distributions here. And that's especially useful for data loads. It's fast, right? There's much less logic involved. Just let the engine do its thing, distributes the data, and then you can work with it. It's obviously, especially for staging tables, a common strategy is to load the data quickly into these staging tables using the round robin distribution. And then based on your workload analysis, you can determine, okay, maybe I've identified an ideal hash key to redistribute that data, and then run a CTAS, a create table as select, taking that data in the round robin table and redistributing it based on the new key that you discovered will improve performance. But obviously, when you're doing a standard round robin, there's no optimization based on the queries itself by default there. It's just everything's evenly distributed, which may or may not work for you. Again, tends to be an iterative process, and it's a matter of monitoring and observing your workload and the typical queries that are run against your dedicated SQL pool. And then, like I said, replicated is the other one, where you have a copy of an entire table for each compute node. So obviously, there's a couple of reasons why you don't want those to be too large. We'll talk a little bit more about that. Essentially, if you scale up or scale down, add compute nodes, well, then you got to wait while these replicated tables are made available for each of those compute nodes. If the tables aren't static, if the data is modified a lot, that adds to overhead as well. So all those things can contribute to your there's always going to be some data movement, but what contributes to excessive data movement that might be slowing down your queries unnecessarily. So how do you find out how big of an issue this is on my dedicated SQL pool? And there are a couple basic queries you can run to identify these issues. So, just like in standard SQL Server, similar system view in your dedicated SQL pools, your exec requests view. Notice it just has that additional little PDW built into it, where you can do, just start by doing a select top 10 and order by total elapsed time. See what are my 10 longest queries that have run on this dedicated SQL pool. Whenever you're looking for query optimization, that's as good a way as any to get started, find out what's running long and is there any opportunity for optimization here. Then once you've identified those, part of the results will include your QID, your query ID. You can then look for the plan for that query. Basically, there's another system view that breaks that execution down into the individual request steps that show you, okay, what was done with the data, what compute nodes were doing what work, how much data movement was going on, and you see there in the bottom there the typical data movement operations that you want to look for. So you can also sort by the way, and I have it in there in the query, order the steps by elapsed time too, right? So your longest steps for an individual query bubble right to the top, and if you're seeing one or more of those move operations accounting for the bulk of the time of that query's execution, you've identified your culprit, what's going on there, and you can look into, again, the query, how is it doing its joins and group bys, how is the data distributed? Is there ways that I can, select a different hash, or if it's an round robin, can I hash distribute it to improve the performance of that query and minimize that data movement? And those, shuffle moves, you see there's a lot of different ones there. All well documented. Essentially you can see by the name, they kind of tell you, okay, I'm doing a lot of shuffling of data back and forth between these different compute nodes because they can't complete their piece of the work until they have their own copy of some of the data that another compute node currently owns, so I can complete that work, and then I'm going to pass it back, broadcasting out to all the different compute nodes and so forth. So you can see the different operations, but essentially you're going to drill down and look for those operations. And if those are accounting for the majority or significant amount of your elapsed time, that's an issue you're dealing with there. So what do you do about that? I've like I said, I've told you a little bit where I've identified that data movement is clearly the overriding issue, why this query is taking so long. Take a look at how they're grouped by, aggregated, how am I distributing that data? And some do's and don'ts that are out there. So again, you can see to select your distribution columns, if you are looking at, okay, how do I hash distribute my table? Are they columns that are typically used in those clauses you see listed there? From the workload that I've so far seen come into the distributed pool. Joins and group by is the most common, but obviously distinct over having clauses. Also, like I said, many unique values for the reasons we mentioned before. And then, along those same lines, what you don't want to do, are look at columns that are used in where clauses. again, if you're distributing by that column and it's something that's often done in Aware, that's likely to then skew the workload to, okay, I know that I'm always searching, and if I've got it distributed that way, that means that, again, I'm kind of defeating the MPP architecture and putting most of the work on the one compute node or one or two compute nodes, again, depending on how your data is distributed and what scale you're at, to where that the data that meets that where clause is stored, and I'm not being as efficient as possible with these resources that I've allocated. Again, date columns, a lot of the, same reasons, they're often used in where clauses, right? So that's, and then depending on the nature of the data, date columns, you think, oh, they're going to be very distinct. Well, not necessarily. Again, it all depends on the nature of your data. And along the same lines, many nulls. A lot of nulls, they're going to end up all on one distribution. Again, you're going to end up skewing your data, defeating the purposes of that MPP architecture. And then, like I said, also consider the proper use of those replicated tables. And we'll talk a little bit more about that here in a little bit too. Let's keep moving forward here. So that's data movement. By the way, a lot of these scripts that I've shown you, either in the slide or I have some that are just, I'm actually going to show you in SSMS. I have links at the end. A lot of these are available, through in the Microsoft documentation. Some of them I've modified and done some work against, and I've got a link to a GitHub repository where you can access those as well if you want to check them out for yourselves, modify them, whatever you want to do there. So I'll make sure that you have access and know where to find those at the end of the session here today. Excuse me. So we talked about data skew already with regards to data movement and the reasons why, data skew in particular is a common issue. So when you're going beyond, the data movement caused by, again, you distribute it by the wrong key that isn't used in the joins and the group bys, it could also be an issue where you just chose a bad distribution column, like the ones that weren't distinct enough, they're nulls, those types of things. In what case you're going to have data skew. Essentially, you have those 60 distributions, and some of the distributions hold much more data than the other distributions. Excuse me. And because of that, some compute nodes are going to be dealing with a lot more data than other compute nodes, and you're not properly scaling out, evenly the workload across the pool here. And it's kind of a weakest link scenario, right? The workload can only perform as fast as the slowest node, more or less, right? If it's doing all the work, it doesn't matter if I'm at a service tier that's got 60 compute nodes. If most of the data I'm working with is on one distribution, it's the one compute node that's going to be doing most of that work. So, of course, remember those do's and don'ts from the previous slide there. And again, it's important to remember data, it may not be skewed when you create the table. When you first distributed it, it might have made perfect sense and the values are very distinct. But if you're doing regular data loads over time, the data can over time become skewed. And so again, why this is an iterative process. It's not something where it's a one and done. I'm going to query my data, create my table, query my data, and then everything looks good and then set it and forget it. No, anytime you're loading data, the nature of the data can change and the data can become skewed. So with that, let me flip over real quick to a quick demo to show you the how to discover if you're dealing with data skew. Here we go. And I actually already ran the query here. And again, I've got links at the end, so you don't have to worry. And I actually performed some mod. This is one where I did modify again. I basically took a version of query that you can find on learn.microsoft.com, rolled it into a CTE, and then just had cleaned it up the results for my own use. Two reasons for this. It's more user-friendly, I think, the way I formatted it, so I have that much more immediate of a view of the information I'm looking at, distilled down to what I'm really concerned about. Also, like I said, I wrote it for our customers that do use SQL Century to monitor their dedicated SQL pools. You can import and automate this and automate alerts and that type of stuff if your query results are basically a key value pair. So that's also why I've kind of modified this query to return the results in that format, key value pair, so I can easily integrate it into SQL Sentry. But regardless, I think it's just more user-friendly, more readable format this way anyway. But you see there's a lot of tables that we're joining on to pull that data together. But essentially, we're taking a look at the data SKU. If I come down here, you can see basically what's going on. We're getting counts for each table, how many rows are on each of the 60 distributions. And essentially what I'm doing here, and again, there's a lot of logic you can modify for your own use here. If the difference between the row with the minimum amount of tables, the minimum amount of rows for that table, and the distribution that has the highest number of rows for that table are off by more than 10%, then that's something I want to be alerted on. That's something I want to see here. And that suggests that, okay, this, again, ultimately everything's going to depend on the queries themselves. And if you're seeing that data movement, is our queries running slower than you think they are? And then see, well, is it because I've got skew? But this way, I've got that visibility right out of the gate. Hopefully I can head it off before it becomes a problem and queries start to run long. But again, every time there's a data load, these values can change. So you want to iterate, with these queries here and get visibility into your data SKU, but with the cadence that the data changes in your environment. So, like I said, the regular version I kind of is in the CTE. I'll share the link. I don't know if I made any maybe slight modifications from what it is shown in the Microsoft article, and then I just rolled it into a CTE and did some further modifications for readability there. But that's how I can quickly and easily identify data SKU based on, it's just the difference of how much of a percent difference is there between the minimum distribution and the maximum distribution row counts. All right. So let's move on to number 3. This is an interesting problem that I wasn't sure was going to continue to be an issue, outdated statistics. This is one that goes back to the beginning, really, of Azure SQL Data Warehouse. And I was having this conversation with some of the Microsoft folks, and they knew that I was PMing our solution, and they came to me and said, "Here, help us help you help our customers. Support calls that we get, the number one root cause for why they're experiencing performance issues is outdated statistics." So I immediately, when I made it back to the office, started looking into how do I get better visibility into this, and how can I integrate that into the product as well to add value to our customers. Again, regardless, you're going to have the scripts here to do it yourself. Interestingly, okay, so when Azure Data Warehouse first came out, there was no auto update statistics. So that was kind of the root of the issue, is every time you did a data load, you had to be responsible. There was nothing that would automatically kick off updating those statistics. So if you weren't aware of that, because you're just familiar with standard SQL Server, which obviously can do that, you could get into trouble, not realize that. And what that basically means, when your statistics get out of date, there's an extra layer as opposed to what you get through standard SQL Server. Because essentially it means that control node, remember, it's a control node the request comes into, and then it knows, or should know, how that data is distributed and what compute nodes have access to what data. So when that request comes in, based on what it knows, it's going to put together the query plan as to how best to return that data, ideally minimizing that data movement. But if your statistics are out of date, what the control node thinks it knows may actually be different than the actual distribution row counts that are out there that the compute nodes have, which can lead to an inefficient query plan put together by the control node. And again, you've got excess data movement. So one of the questions, so first of all, you see the second bullet there is, the update stats, it's been added. It is part of the product now. And so I've been talking to customers, still, since this became Synapse Analytics, the dedicated SQL Pools. is this still an issue? Are you still dealing with this, or is that kind of resolved things? And overwhelmingly, the customer I've talked to, oh, no, it's still a problem. That outdated statistics are still something that are causing us grief. This is still valuable to investigate and know about. So I'm like, okay, that's important. Thank you for that feedback. I want to make sure that nothing that I'm going to drop there. This is still a valid point. But just wanted to mention that I wasn't sure. It was interesting that originally auto update wasn't even part of the product. Even after the fact, it still remains an issue. Shouldn't be a big surprise. It can be in standard SQL Server as well. So again, you see the bullet points there, why it can lead to issues. So there's a couple of things now that we can do when we're looking into outdated statistics. So let me jump back over to the demo screen here. We're doing for time. Okay, I got to make sure cover everything here moving forward. So let me bring up. So first of all, wait, that's not the one I wanted. Sorry about that. Here we go. So obviously the first thing you can do is query and check for the last updated date on your statistics. Again, similar view to you would do in SQL Server. This is a query that you can find out there on the Microsoft site. I think the one that was originally filtered by user created, I just took that where clause out just to see everything. So that's the first thing I can do, see, well, how old are my statistics on all these different objects? I can tell the user created, along with the auto update there based on the naming convention and so forth. Of course, the issue with knowing the last updated date for your statistics, that alone doesn't necessarily tell you that that's going to be an issue. And by the way, yeah, I can, with these, I should still have, oh, I was going to do that. Try again. So you run the query and brings up the data here. But that alone isn't necessarily an issue, right? Oh, can no one see the demo? Is that what you're saying? Sorry about this. Is it not sharing? Maybe I flipped over. Oh, sorry about that, folks. I know what I need to do. Give me 1 second. Let me change my sharing. I didn't even realize that when I popped over the last time. I was probably sharing just the PowerPoint instead of the screen. So sorry about that, guys. Like I said, I'll be providing all the sorry about that. I'll be providing all the information here, links to the scripts and everything. Is that better? Or is everyone seeing Management Studio now? Hopefully.
Yeah.
Okay. Sorry about that. I missed that. Luckily, I'm keeping an eye on the chat here, so I appreciate you mentioning that. So the last one was pretty straightforward, by the way. I could flip back over that here in a second, but you can see here in the statistics again. I just made a slight change where I took out, it's not filtering by just the user created. So what I do, I've got my last statistics update. I can see that. The point I was going to get to, though, here is, again, this is similar if you're familiar with just in SQL Server, what it's going to look like there. Just because the statistics haven't been updated recently doesn't mean they're out of date. Depends on how dynamic the data is. So this alone doesn't give me a complete answer, right? It might point me in the right direction, but I still have to understand the nature of the data, and all that to make this valuable. So another thing that is out there that I've modified is, instead of looking at the statistics dates, and this is a much more complicated query that I've worked with, and again rolled into a CTE to make it more reader friendly. It actually goes out and just does actual row counts. What does the control node say the row counts are for this table, compared to what do the compute nodes, what is the actual row count in the distributions, and then see if there's a difference. If there's a significant difference between those two, what the control node thinks and what's actually out there, then I know that I've got a statistics issue, and it's likely going to result in an inefficient query plan. You see, if I scroll to the bottom here, I just change it up so it shows me a percentage difference. So again, just some slight modifications there. Again, I'll share those differences. Again, just makes it more reader friendly, so I'm not just looking at row counts. But there you go. So being able to quickly identify, so we looked at skew before. I'll flip back over that for a second for those that didn't see it. Like I said, I'll share the script as well. And percentage difference. And just think again, I'm trying to distill it down to give me as quick and an obvious answer as possible. So I like to go with those percentage differences. I did with the skew. What's the percentage difference between the min and max? Here I am with the difference in row counts too. It gives me a good overview of, okay, how likely am I to run into query performance problems there? Thanks for pointing out. Let me just real briefly, just so you can see it. There are the results from the skew one. And again, I took this query, rolled it into a CTE, and then distilled it into the data that you see there. So that's the skew percentage one from before. Sorry about that, guys. All right, let's flip back here. Moving along with the time, got about 10 or so minutes left here. So next is concurrency limits, and this has changed over time as well. And I wanted to start by talking about resource classes because I've had a lot of conversations about this. They're still out there, but the resource allocation method has moved to workload management. So I want to make sure to talk about that as well. If you're familiar with Resource Governor, that's been in SQL Server for a long time, same concepts there, setting up your resource class, your workload groups, classifiers, and all that. And it determines for each request how much of the total resources of in this case, the SQL pool, does any particular request or group of requests get. Don't want to drill too deep down that rabbit hole. You could spend a whole hour just talking about all of that. The main point is you can see here, both with the resource class setup itself, along with, you see the concurrency limits there, that regardless of that, if you're at the lowest service tier, your maximum concurrent queries are 4. That it can only handle 4 requests at any given time. Anything else that comes in is going to be suspended and held in queue until availability opens up to start that request. And it does go up. Now, see, this is, again, based on the old configuration using the resource, or sorry, using the resource classes. Let me flip over to here. It's changed a little bit using the workload groups. Of course, 4 is still the bottom tier there. But even if you go all the way to the top several tiers there, the maximum concurrent queries are 128. So again, depending on how busy your dedicated SQL pool is, again, this isn't a transactional system, right? It's meant to be, it's OLAP, it's meant to be analytical. So it's not expected that you're going to have thousands of transactions per second. But this can still catch you off guard and become a common issue. And again, it's something that I do run into when I'm working talking to customers in the field. So just be aware, depending on what service level you're currently set at, and obviously you might be scaling multiple times a day, or whatever that whatever you need there, be aware that that's going to change the maximum concurrent queries that can be handled at the same time. So how do you tell if that's going on? And this one I've just got up in the slide here because it's pretty straightforward. Again, going back to that PDW exec requests, where, again, similar to what you see in SQL Server, if the status is suspended, that means that it is actively being queued. Right? It is out there. It's been received by the control node, but you've already hit your limits for the concurrent queries, and so that request is in that suspended state. You can have it ordered by submit time there, so you can see it chronologically. Some things to be aware of is this view does only hold a max of 10,000 rows. So depending on how busy your SQL pool is, that can be flushed out in hours, days, it all depends. Just be aware of that. The max is 10,000 rows. One of the benefits of a third-party tool like SQL Sentry is that's synchronized and can be held longer in a separate repository. But focusing on the native tools here, that's a limitation. And again, it's suspended, by the way. It's not only applied to those concurrency or query limits, but it's probably the most common that I see there. And know that, again, that's only when it's active. So that doesn't mean that if you see something, there's nothing suspended. It doesn't mean that it's never happening on your your pool. It just means it isn't actively happening right now. You can drill down, you see there the DM PDW weights to get a little more details on why it's suspended. You can see the weight type there if it is a concurrency issue as opposed to possibly something else. And again, suspended only when it's actively being queued. If you're looking after the fact, the query finally did run, but it was queued for a long time because of the concurrency limits. But you want to go back and find that. It'll show up as completed in that same view there, but you're going to want to look for a big difference between the submit time column and the actual start time column. If there was a huge gap in time between those two, odds are it was because it was suspended because of that concurrency limits being hit. Again, no guarantee of that, but it's a pretty good indicator. It's somewhere to look. So you'll have the full workload there. You can see by the timestamps if that was likely what was going on there. By the way, some things that aren't limited by concurrency limits, quite a exhaustive list here. So obviously anything to your standard selects where you're pulling up data for your analysis is going to. Important to know, obviously selecting from these system views, where we're walking through all these examples is querying the DMVs, those don't go against your concurrency limit. So don't think that you're going to contribute to the problem by querying these DMVs. They bypass those limits. Obviously, you need to have access to view the information to troubleshoot a problem, along with the complete list that you see there. So let's keep moving on. I want to make sure that I stay on time here. The last one, large replicated tables. I started talking about this, introduced it at the beginning here. There's no hard limit to how large is too large for a table to be a replicated table. Best practices suggest no larger than 2 gigabytes. Again, it's an efficiency thing, right? Because the larger that table is, so is there anything to stop you from, I don't know, I haven't, experimented to see if there's technically, according, quote unquote, there's no limit. So you got a terabyte table that's replicated. When you think about that, each time you scale up or scale down, that's going to be huge overhead to replicate that table out so that all the compute nodes have their own copy of the table, because that's what a replicated table is. Instead of distributing it and sharding it across those distributions, you're simply creating an entire copy of that table for each compute node. Like I said, 2 gig is the kind of the best practices, but there's other factors to consider. If the table to data is really static or completely static, it might be less of an issue. It depends on how often you're scaling up and down your environment too, those types of things. And you can use, if you want to find out, well, how big is are my replicated tables? If you know the tables that are replicated, first of all, there is DBCC PDW show space used, but that's not the most, again, user-friendly way to do it. If I flip back over to my demo, which this time should be visible for everybody, let me bring up, so first of all, let's see, this is 5A. So there's if I do PDW, show space use, I picked one of my replicated tables. This is what the results look like. So you can see it's broken down by distribution. I've got my reserve space, data space, index space, and then nodes. But I've got to kind of add things up, know what I'm looking at here to come up with an idea and see, well, how big is this table, based on adding up and depending on how many compute nodes you have. Again, I'm for efficiency and simplicity. Let's make this user-friendly and readable. And if it's, integrates better with SQL Sentry as well, so I've got that motivation, here's the query where I've already taken that information, done all the aggregations, and provide the results to show. Here's the 2-part name of the table, and there's the size in gigabytes. And this is a little demo environment I've got, so nothing too crazy big here. These are well below the 2 gigabyte limit. But that's all it is. So again, makes it that much easier. Filters on just the replicated tables, but I don't even need to know which tables are replicated. The query does that for me too, and shows me the size. So again, about being efficient with my queries, I want to know this information as quickly as possible. I want to avoid any of the extra manual effort. Get to those details. So let's wrap up. We're right on time here. So that was the demo here. Wrapping up. So we talked about the 5 main issues that I've most commonly run into that seem to have the biggest impact. Data movement, regardless. And that's something that the number one thing, find the longest running queries in the exec request view, take the QID of the longest one, then look at the individual steps, sort it by the duration time, and look for those movement operators as the top steps for that query plan. We talked about skew. It lends to excess data movement. Obviously, a lot of this, ultimately, it's about data movement, right? Whether it's just because how you distributed your data or these other issues here. Skewing your data so it's not evenly across your distributions can lead to one compute node doing much more of the work than others. Outdated statistics. Again, the control node has a different idea of where the data is as opposed to where it actually is distributed down there. The compute nodes. Inefficient plan leads to excess data movement. Concurrency limits. Now, here's one that's not really related to data movement, but just being aware based on the scale that your service tier that you're currently set at, that can be an issue. At the very bottom tier, only 4 concurrent queries max are allowed. And obviously, it can be even less than that, depending on how you set up your resource classes or workload groups. If you allocate more resources, one query can take up everything, right? And then large replicated tables we just touched on here. So these are the most common I've come across. There's plenty others, TempDB, low memory, things like that. There's lots of documentation out there that goes into those as well. But these, in my experience, have been the top 5 most common that I've seen or customers have brought up. A lot of good information out there. And of course, now we're starting all over with Microsoft Fabric. So it's been a lot of great content here today on Fabric already. I'm looking forward to get deeper into that myself. And here's a quick, again, the point here, get these resources. If not, feel free to check me out on LinkedIn. I'm happy to share the information with you. You see a lot of that, at least the starting queries, the ones before I modified them to make them a bit more user-friendly. You go right out to learn.microsoft.com. A lot of great content there. Also, if you are looking for a third-party tool to automate a lot of this, again, I appreciate it's my experience with SolarWinds SQL Sentry that educated me on all this in the first place. And it's been then poured back into the product. If you're looking for something like that, appreciate you checking it out. And then my GitHub link too for the scripts directly, so you can have those copies yourself, modify them, customize them for whatever comes best in your environment. I know we're right up at time here. I've been watching the chat here, and so again, thank you for letting me know you couldn't see the SSMS before. I'm sorry about that, but again, I think everything was pretty straightforward, and all the information is going to be shared out there in the GitHub. Any other questions, type them in now while we're at the end. Otherwise, I want to thank everybody for your time and interest today. I appreciate being able to speak to everybody. I'm looking forward to seeing more sessions.